Okay, hello, how are we all doing? All right, so we're up to Module 9 of Switching, Routing and Wireless Essentials. So FHRP concepts, and that's first hop redundancy protocols. So we'll look at the purpose and operation of first hop redundancy protocols, and we'll have a bit of a look at HSRP, which is Hot Standby Routing Protocol, which is a Cisco proprietary one. Okay, so let's talk about them in general. So, of course, there is a bit of limitation with gateways. End devices are typically configured with a single default gateway for IPv4 addresses. If the default gateway router interface fails, LAN hosts lose outside LAN connectivity. This occurs even if a redundant router or layer 3 switch can serve as a default gateway. And so the first hop redundancy protocols are mechanisms that provide alternate default gateways in switch networks where two or more routers are connected to the same VLAN. So one way to prevent a single point of failure at the default gateway is to implement a virtual router. To implement this type of routed redundancy, multiple routers are configured to work together to present the illusion of a single router to the hosts on the LAN. By sharing an IP address and MAC address, two or more routers can act as a single virtual router. So the IPv4 address of the virtual router is configured as the default gateway for the workstations in a specific IPv4 segment. When frames are sent from host devices to the default gateway, the hosts use ARP to resolve the MAC address that is associated with that IPv4 address for the gateway. The ARP resolution returns the MAC address of the virtual router. Frames that are sent to the MAC address of the virtual router can be physically processed by the currently active router within the virtual router group. A protocol is used to identify two or more routers as the devices that are responsible for processing frames that are sent to the MAC or IP address of a single virtual router. Host devices send traffic to the address of the virtual router. The physical router that forwards this traffic is transparent to the host devices. So a redundancy protocol provides a mechanism of determining which router should take the active role in forwarding traffic. It also determines when the forwarding role must be taken over by a standby router. The transition from one forwarding router to another is transparent to the end devices again. So the ability of a network to dynamically recover from a failure of a device acting as a default gateway is known as first hop redundancy. Okay, so basically what happens for a failover. And so you can see on the diagram here that there's actually two physical routers. And so that's these two outer ones. And together, as a team, they create this virtual router. And it's the virtual router's details are what's given to the hosts. And so, of course, at the moment, apparently this router is the active one because this link or device failed. And so it will have actually switched. Everyone is still using the virtual router, but it just goes that way instead of previously would have gone that way. So when the active router fails, the redundancy protocol transitions the standby router to the new active router role, as shown in the figure. These are the steps that take place when the active router fails. So the standby router stops seeing hello messages from the forwarding router. So of course they need to keep track of one another to make sure that they're still going. The standby router assumes that the role of the forwarding router. Because the new forwarding router assumes both the IPv4 and MAC address of the virtual router, the host devices see no disruption in service. Well, they might see a little bit, may not detect it instantly, but yeah, I'm going to say there might be a slight pause, but it will fix itself automatically. All right. So what options are there for first hop redundancy protocols? So there's HSRP, which is a hot standby routing protocol. So there's a version for IPv4 and one for IPv6. And so, of course, that's a Cisco proprietary protocol. And so it works pretty much exactly how that description described it. And so HSRP is used to in a group of routers for selecting an active device and a standby device. The active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. And so then there's another routing protocol, FHRP, and so we're up to version 2. And so virtual router redundancy protocol. So this is non-proprietary election protocol that dynamically assigns responsibility for one or more virtual routers to the FHRP routers in an IPv4 LAN. This allows several routers on a multi-access link to use the same virtual IPv4 address. And in FHRP configuration, one router is selected as a virtual router master, with the other routers acting as backups in case the virtual router master fails. And so FHRP version 3 supports both IPv4 and IPv6. So there is also GLBP, or Gateway Load Balancing Protocol. Again, this is Cisco proprietary. And so with that, it protects data traffic from failed router or circuit, like HSRP and FHRP, while also allowing load balancing, also called load sharing, between a group of redundant routers. And so you can get better utilization of your redundant equipment. And so basically, again, we got GLBP for IPv6 as well. And so again, of course, it's a virtual router that, of course, is what's used. And so then there's also ICMP Router Discovery Protocol, or IRDP. And so it's a legacy FHRP, and so it allows IPv4 hosts to locate routers that provide IPv4 connectivity to other non-local IP networks. But yeah, not a lot use it anymore. So let's talk about HSRP in particular. And so it provides a way to avoid losing outside network access if your default router fails. It is Cisco proprietary that is designed to allow for transparent failover of a first-hop IP device. It ensures high network availability, providing first-hop routing redundancy for IP hosts on networks configured with an IP default gateway address. It is used in a group of routers for selecting an active device and standby device, or devices. In a group of device interfaces, the active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails, or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of the HSRP group and to quickly assume packet forwarding responsibility if the active router fails. Okay, now there are some settings you can do. So the role of the active and standby routers is determined during HSRP election process. By default, the router with the numerically highest IPv4 address is elected as the active router. However, it is always better to control how your network will operate under normal conditions rather than leaving it to chance. So HSRP protocol can be used to determine the active router. The router with the highest HSRP priority will become the active router. So by default, the priority is 100. And so if you change the priority to be something higher, like in the diagram example says 150, so that router will become the active router typically. If the priorities are equal, the router with the numerically highest IPv4 address is elected as the active router. To configure a router to be active router, use the standby priority interface command and the range from 0 to 255. So of course, you're going to have to get a bit higher than 100 probably to make it the active router. Okay. So by default, after a router becomes the active router, it will remain the active router even if another router comes online with a higher priority. To force a new HSRP election process to take place, when a high priority router comes online, preemption must be enabled using the standby preempt interface command. Preemption is the ability of a HSRP router to trigger a re-election process. With preemption enabled, a router that comes online with a high HSRP priority will assume the role of an active router. Preemption only allows a router to become the active router if it has high priority. A router enabled for preemption with equal priority but a high IPv4 address will not preempt an active router. Refer to the topology in the figure. Note, with preemption disabled, the router that boots up first will become the active router if there are no other routers online during the election process. So again, we've got this active router priority of 150 and the standby router is the default 100. And by putting in that standby preempt in the config for that interface, even if this router is up in the active router, if this one boots, it will actually trigger a new election and it will end up becoming the active router. Okay, so what states does HSRP go through? So it starts in the initial state, and so it's entered through a configuration change or when the interface first becomes available. Then in learning mode, the router has not determined the virtual IP address and has not yet seen a hello message from the active router. In this state, the router waits to hear from the active router. In the listen mode, the router knows the virtual IP address, but the router is neither the active router nor standby. It listens for hello packet messages from those routers. In the speak mode, the router sends periodic hello packets messages and actively participates in the election of the active and or standby router. And of course, the mode of standby means the router is a candidate to become the next active router and sends periodic hello messages. The active and standby routers send hello packets to the HSRP group multicast address every 3 seconds by default. The standby router will become active if it does not receive a hello message from the router after 10 seconds. You can lower these timer settings to speed up the failover or preemption. However, to avoid increased CPU usage and unnecessary standby states, do not set the low timer below 1 second or the hold timer below 4 seconds. So as I said, there could be some disruption, but your maximum of 10 seconds will be how long it takes. Okay, that's it for the chapter. Actually, it's not a big chapter. So first top redundancy protocols provide an alternate default gateways in switch networks where 2 or more routers are connected to the same VLANs. One way to prevent a single point of failure at the default gateway is to implement a virtual router. With a virtual router, multiple routers are configured to work together to present the illusion of a single router to host on the LAN. When the active router fails, the redundancy protocol transitions the standby router to the new active router role. These are the steps that take place when the active router fails. So the standby router stops seeing hello messages from the forwarding router, and so after the timeout period, so as we said, 10 seconds, it will actually then assume the role of the forwarding router. Because the new forwarding router assumes both IPv4 and MAC address of the virtual router, the host devices see no disruption in service or only momentary. The FHRP used in production environment largely depends on the equipment and needs of the network. So these are the options available. So there's HSRP for both IPv4 and IPv6. VRRP versions 2 and 3. Of course, 3 supports both GLBP for IPv4 and IPv6, and the old one IRDP. Okay, so HSRP is a Cisco proprietary protocol designed to allow for transparent failover of a first stop IP device. HSRP is used in a group of routers for selecting an active device and a standby device. In a group of device interfaces, the active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of HSRP group and to quickly assume packet forwarding responsibility if the active router fails. The router with a high HSRP priority will become the active router. Preemption is the ability of a HSRP router to trigger the re-election process with preemption enabled. A router that comes online with a higher HSRP priority will assume the role of the active router. HSRP states include initial, learn, listen, speak, and standby. Okay, so that would be the end of the chapter, and so I will do a demo shortly, and so I'll see you next time. Have a good one. Bye.